In this lesson, we're going to talk about the graphs of polynomial functions. You can see in your table, you have at the bottom of your notes, you have this little thing about graphs of polynomial function. It talks about how if both arrows go up or down, the degree is even. If both arrows go in opposite directions, the degree is odd. And to find the number of real roots, you see how many times the graph crosses the x-axis. And then you'll kind of see this weird table that I'll explain in a while that has all these infinity symbols. So as you're looking at this one, if both arrows go up, meaning, and these graphs don't actually have arrows, but if they continue, this is how we draw the arrows, right? And this graph, it looks like this. So the first graph is an example of a quadratic equation. Quadratic equation crosses the x-axis twice, unless it has imaginary solutions, and my arrows are both going up. The other option I would have for a parabola is for both arrows to be going down. I don't have any other options for quadratics. So any x squared term is going to have both arrows go up or both arrows go down because the degree is even. Think of x to the fourth. If you wanted to on your graphing calculator, you could graph x to the fourth, and you would see that your arrows are either both going up at the end or both going down. It's going to be a little bit more of a different kind of graph, but it looks something, let's say, here's an example of one. It looks something like that, where both arrows are going down. Same with x to the sixth, x to the eighth. Those are not functions we work with a lot, but that would be true for them. In this cubic function here, you can see that I have my arrows going opposite directions. And so this is a cubic function, crosses the x-axis 3 times. So this is an x cubed. Think of an equation of x to the first, another odd degree. That graph, arrows are going in opposite directions. So just by looking at a graph, even if you don't know what type it is, because of the way the arrows are going, you could say if it's an even or odd degreed problem. That's something you could tell just by looking at it. The other thing to point out is that the number of real roots, so that's how many, not imaginary roots, it counts how many real roots it has, is how many times the graph crosses the x-axis. We've done that with parabolas, and so now we're looking at it with cubics and others. This graph you see here happens to cross 3 times. So we know right here, these 3 times. So we have 3 real roots. The one that's in the board in our classroom looks like this, and we only cross once. So this is 1 real root, which, because I have to have 3 roots, means I have 2 imaginary roots. So now, given these graphs, we're going to answer some questions about them. Before we do that, I want to kind of explain what this weird looking table is that you see, this coordinate grid. You'll see this says as x approaches positive infinity, this is how I would read that math-wise. As x approaches, that's the arrow, positive infinity, f of x approaches positive infinity. So it's saying as the x's get bigger, the y's are getting bigger. This is basically just a really fancy way of doing the sign chart you did in middle school. So when you first learned to plot points, even in grade school, you would plot like this point 3, 1, and your teacher would say, oh, all these points in quadrant 1 are positive. And then when you go to quadrant 2, you have negative x's and positive y's. In quadrant 3, you have negative x's and negative y's. And in quadrant 4, you have positive x's and negative y's. So hopefully you remember that chart. This is just us advanced algebraing it, we can call it. That's going to be a verb now, apparently. So we're going to say that this is a fancier way to write that, and we're going to write it with more mathematical terms. So as you move on in math, sometimes they make things look really confusing, and it actually makes a lot of sense. All they're telling us here is that this chart is true. Look at the second quadrant, for example. As the x's get smaller, so picture x is getting smaller, anywhere I go in this graph, let me plot some points here, right, as I'm drawing this line. As my x's are getting smaller, so notice the x is going this way would be negative, right? What's happening to my y's? They're getting bigger. That's all this is saying. As the x's get smaller, the y's get bigger. And it's kind of a play off how we write domain and range a little bit too, because we're used to using infinity for that. And so the same thing would be true for quadrant 3. As the x's get smaller, they go this way. The y's are going this way. If it's going down here, the y's are going lower too. So as x approaches negative infinity, so does y. And they'll call it f of x because they have it in function notation. So hopefully that makes sense to you. It's not something you have to memorize, it's just something we're trying to introduce to you and get you to practice. So for today when you're doing this, you will probably just copy off of this table, and then hopefully you use it enough where you kind of get to see what that means and you'll be able to just do it naturally. So the first thing we'd ask with question A Hopefully you can tell this question is a parabola, and after studying parabolas you would be able to tell me that the a is negative because it goes down. You could even maybe tell me something about its shape because it's a little bit skinnier, so maybe you would say that it has an a of like 2 or 3 or something like that. But all they're asking is the degree even or odd? So because both of my arrows are pointing downward, they're both going the same direction, I know my degree is even. And then it says define the end behavior. So all we're going to do is we're going to look at where these arrows are, and we're going to list where they are as far as this chart right here. So I see both arrows in quadrant 3. So I'm going to say my end behavior is that right there. So you're just going to copy that. You're going to say as x approaches negative infinity, f of x approaches negative infinity. For what we're doing right now, we're going to call that good and not try to do anything more than where you see your arrows. Some of you might be noticing that we know this parabola will naturally get wider as it expands, and maybe it would go into this quadrant, and so maybe the end behavior would be in that quadrant. But for just the beginning of learning this, we're going to just talk about where we actually see the end visually when we can look at it, and we're not going to make any predictions about where that parabola is going. So there's my end behavior. And then the last thing it asks me is, how many real zeros are there? So remember, that's another way to ask how many real roots or how many real solutions. So how many times does this graph cross the x-axis? 1, 2. So there are 2 real zeros. What I'd like you guys to do right now is to pause the video and do what you can with B, C, and D, and then we'll come back and talk about them. So you do B, C, and D quick, and then unpause it, and you can see me show you what we got for an answer. So in B, hopefully you notice this is a cubic function, we think, right? It looks like opposite directions, so we're going to say it's odd. The end behavior, one of the arrows is ending in quadrant 3, and one is ending in quadrant 1. So I'm going to list both of those as my answer. So I'll list quadrant 3 first. Doesn't really matter, you can choose. So as x approaches negative infinity, f of x approaches negative infinity. And then quadrant 1. As x approaches positive infinity, and you don't have to put the plus sign there if you don't want to, f of x approaches positive infinity. So we're telling someone who can't see this graph where the end behavior is, so where those arrows are, and they could maybe sketch it from there. Next, it's going to ask how many real zeros we have. So I count how many times I cross the x-axis. I see 3 there, so I'm going to put a 3 right there. Letter C. Hopefully you recognize that's a linear function, and so we say odd or even. Well, these arrows are going in opposite directions, so this would be odd. Its end behavior is in quadrant 2, which is this one, and quadrant 4, which is right here. So I'm going to actually list both. I would say as x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches negative infinity. And again, you wouldn't have to put the plus signs there if you don't want to. And then how many times does this graph cross the x-axis for real zeros? That's 1 time, so I have 1 real zero. The last one is a really funky looking graph, right? So when I look at this one, is it odd or even? I don't know if this is, I know it's not an x squared, right? I know it's even because both arrows go up, so I'm going to say even. It's not an x squared, and really we don't know enough yet to say what it is. It could be an x to the 4th, maybe it's an x to the 6th. I'm not really sure how you determine how many zeros there are right now in our class, right? So we don't know beyond that. I think all of us could say it's not x squared because it does not look like a parabola. The end behavior is in quadrant 2 and quadrant 1, so those are the 2 I would list. So as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches positive infinity. So that tells you the end behavior. How many real zeros are there? Where is this graph crossing the x-axis? Nowhere. So my answer for that would be 0, which means if I had this equation and I was going to solve it, I would get only imaginary solutions. Hopefully that made sense to you. If you have any questions on that, you can ask me tomorrow.